Okay, so welcome to another IT computer science class. Today we'll be touching on the wonderful topic of pseudocode. Do you know what a pseudocode is? Can you think what a pseudocode might be?
Something that would do involve a lot of coding.
Well, close enough. It's really what is written before you actually start with the actual coding. So basically, it's a notation representing a simplified programming language. So basically, it's what you put pen to paper when you want to write a code, and then you put your thoughts together and see how the code would basically flow. So we're going to watch a short video on pseudocode. Okay.
You can make some pretty complicated programs that use many different data types, conditional logic, and your own custom. At this point, you can make some pretty complicated programs that use many different data types, conditional logic, and your own custom functions. Let's look at how we can use pseudocode to help us brainstorm and plan our code before we write it. Writing pseudocode is writing down the logic and steps of your code in plain English before you put it into the syntax of a specific coding language. Why do we want to take the time to do that extra step? Pseudocode is easy to write and helps you figure out the logic of a problem so that you can communicate what you're doing and don't run into errors later. It saves a ton of time during the ideation phase of writing a program, and you'll use this skill in any software engineering job, even at the senior level. I've written pseudocode during many team meetings because you can quickly whiteboard a problem and talk about technical solutions even with non-technical team members who might not know any programming syntax. Many software engineering recruiters even say that it's a red flag if they see someone jump into coding during an interview without making a plan in pseudocode first. So, how do we write pseudocode? To write the pseudocode for a program, we write each step of our code in plain English from top to bottom and use keywords to describe the different control structures that we would use in Python. Let's look at examples for some of the Python topics we've covered so far. If your program requires output, instead of writing out the print function in Python, we would use a keyword like print or display to describe what the code will do. If your program uses input, use keywords like read or get and describe how you'll prompt the user for that input. To describe a calculation that you're doing in a Python expression, we would use math terms that you would normally use when talking about those computations, like divide. Assigning variables can be described as save, set, or store. And more complicated code flows, like conditional logic, can use very similar keywords to their syntax in Python because Python uses almost plain English for these statements. Here's the Python code for an attendance tracker. So to describe this conditional logic in pseudocode, we could write the same code like this. Let's put all these pieces together and pretend that we're software engineers at a company that's building a food review app. If the project manager asks me how I think we should implement a message to tell restaurant owners that they just got a new rating, I might imagine this Python code in my head. The user inputs their rating, and then we send the message to the restaurant owner based on the value. What I would actually draw on the whiteboard, though, is something more like this. No matter who is in the room, they'll be able to understand the logic that I'm suggesting for the app, because it uses simple keywords and plain English to describe the logic from start to end.
Okay, so we have a better understanding
Hi everyone, my name is
of
Carlos.
pseudocode and the reason why we use it. So from what you just watched, what's your understanding of a pseudocode?
Pseudocode, you should write a like steps in English from top to bottom before coding it. Yeah,
Well, that's very good. You got the main essence of the reason why we write a pseudocode and how useful it is before you actually start the actual coding. Now, we're going to write a pseudo. I want you to think of a simple problem and tell me how you write the pseudocode. For example, let me suggest a problem. Adding 1 plus 1. How would you go about writing the pseudocode for 1 plus 1? First, we'll accept one number, accept number A, then accept number B, and then add A plus B and print result. So you see that's almost the form of the pseudocode from top to bottom. This is the sequence also in how the code would be written. So you already have an understanding before you actually start writing the actual code to solve the problem. Okay. So we're going to look at some pseudocode examples. Pause this video. Okay, so here we have two pseudocode examples. For the first one, we're going to look at this pseudocode and analyze it. So we're to write a pseudocode to find the largest of two numbers. So the first thing that we're going to write is begin, to show that we're starting the code. Then we're going to write something to accept two numbers. So we're going to, as you see here in line 4, we have numeric 1, numeric num1, and numeric num2. Here we have display. To simply print on the screen, enter the first number. So now the user would see this come up, and now what do we want it to do next? We want it to accept the number that is entered. So we have input and input num1. Now the next thing that should come up in the sequence of code is to display enter second number, and after that would input num2. Now this is where the conditional boolean comes in. So if num1 is greater than num2, display num1 is larger than num2, else display num2 is larger than num1, and then we have the end. So you see the pseudocode is using standard or general English syntax. So even someone who is not familiar with coding could understand, as what was said in the previous video before. So now you as a top-notch A-scholar programmer hired by a multi-fortune company, and you have to present a solution to your boss. Now this is the best way to present it to your boss, explain to him how the code would work. Because when you see all of those syntax and the slash and some of what not going to make sense to him, he cannot read it and understand. But if you present this to him, he can say, okay, this code can work and I approve it and it makes sense. Now this one, write a pseudocode to find this.
one question.
Yes.
So when we are doing the pseudocode, we should always start with begin.
Yes, because the begin shows that the code is starting. This is the start. So to start the pseudocode, we have begin, and to end the pseudocode, to show that we're ending the program, we have end. And that's a very good question.
So without begin and end, the pseudocode will make no sense?
No, it won't make any sense, because basically you're saying that the program has not started or ended. And a program have to initialize and it has to end. Okay. Now here we have write a pseudocode to find the sum of two numbers. Now can you explain to me what's going on here? So it says begin and it accepts yes. There you go.
So it begin for line 2, line 3. Now you have numeric num 1, num 2, and then sum. So for display, which is line 4, you have enter the first number, which will be
Okay,
set
speak
num
up.
1. Alright. So for line 4, you will have
Yeah.
display enter the first number,
Yes.
which will be accept num 1. So for line 6 now it will be display the second number, accept num 2, which is line 7. So for line 8 you will have compute n sum equal n num 1 plus n num 2.
Yes.
For line 9 now you have display sum of these numbers, n sum n. So n num 1 plus num 2, you will have the sum in line 9,
Yes. Yes.
which will equal the n sum,
Yes. Which will equal to the total
Yeah.
of the num 1 and num 2.
which will lead you to the n.
Yeah, so basically, you can see the flow of this program, and even someone that's not familiar with it can actually read it and say, oh, I'm gonna add 2 number. Yes. So that's basically the essence of pseudocode. I know this here's another example where it says to write the pseudocode to find the sum of 3 numbers. It's the same thing, it's just one additional line that was entered. Okay, so it's one additional line was entered and it's just adding the third number to it.
Okay.
Okay class, welcome to another class. Today we'll be going through flow charts. Do you have any idea what a flow chart is? Have you ever heard the term flow chart?
Flow chart, in my words, I think that flow chart would be like this, like for numbers between like you have 0, 1, 2, 3, like the sequence it goes down in.
Well, you're very close. It is a sequence, but it shows a graphical representation of how a code flows. Remember in our last class where we did pseudocode and we could write the code in English, and it still shows you the flow written. Well, this is going to show it to you graphically using symbols and a simpler form of displaying how the code works. For those persons who don't really know, like if you have an impatient boss and no one wants to only word, this is a much simpler form because pictures are easier to understand than for someone who don't have time to read and Okay, so we're going to watch a short video explaining the symbols of pseudocode.
The flow through program. So again, going back to our cup of tea program, we can express it as a flow chart like this. We start with the symbols here. So I'll just put here what the symbols mean within our flow chart. Okay, so we start with a start, which is this kind of rounded style rectangle almost. Okay, and this just signifies the start of our program. Okay, We can then use an arrow which shows progress of the data through our flowchart. So we'll go there. And the first thing we want to do is fill the kettle. Now, filling the kettle is a process. Okay, a process. So it's a thing that happens in the program. Okay, that's what a process is. So if I draw a rectangle, it's a really bad rectangle, and fill the kettle. I do my best to squeeze my writing in here. Then we go down to the next part of the program, which is another process, boil the water. Okay, and then we go down to the next part of the program, which is get our cup and tea bag. Cup plus tea bag. Okay. And then we go to our next part of the process, which is a boil the water. And what we can do for this is boil the water for 2 minutes. So we could make this a decision box. Okay. So boil water 2 minutes. Okay, so is the 2 minutes up? If it's not, we send our arrow back here. If it is, 2 minutes is up, then we send our arrow onto the next process, which is take tea bag out. Okay. There we go. And then add milk. So again, this can be another decision. I'm not quite sure I'm going to squeeze this in. What I'll do, I think, is we'll just move on to the next part up here. Okay, and we'll put a decision up here. That's not the greatest diamond ever. So add milk until happy with the colour. So if we are happy, we'll go on to the next part of the program. If we're not happy, we'll just join background and keep adding the milk. Okay, but if we are happy, the last part of our process is drink tea. Okay, and then we'll finish with a stop. Okay, so if you remember, the start and end is this symbol up here. So we'll finish with a sort of curvy rectangle and write stop. Okay, it's just so we know that this is the start of the program, this is the end of the program. Okay, the only thing we've missed there really is an input. Okay, so I suppose we could have had that up here. So we could have had an input add milk if we were kind of thinking about this a bit more carefully. But an input is normally where a user has to put something into the program, maybe a command like yes, no, something on those lines. Okay, but what we've essentially got here is a flowchart with pretty bad handwriting for making a cup of tea.
Okay, so we had a very quick demonstration of flowchart right there and how it is used. So I kind of jumped the gun a little bit. Alright, so from the demonstration that we just saw, realize that rectangle is the process and a diamond is for decision making. The rhombus accepts input or output. The connector is a circle, And this shape here is for display. We won't be focusing on this one much. And this one is for start and end. You get it? You have to focus on because you're going to get a test afterwards. Alright? So basically, you can, anything that can be written in code can be drawn up in a flowchart format. Flowchart format. Alright? So here we have on the board, we have on the board here the symbols, and I want you to match. You're going to match the correct symbol to its purpose on the right. Think you can manage that? Okay. Show them that you're a quick learner. Okay, let us see if you got them correct. You think you got them all right?
Yeah. Yes.
Okay, let us see. Okay, so you said the rectangle is actually a process and not input. So this one should go here. Okay, but you're not looking bad. Let's see about the rest. The diamond, decision making, correct. You got that one right. That's very good. Wait, I'm getting shapes wrong. Okay, the diamond, decision making, and the rhombus. The rhombus is actually input and output. Alright. This one, also correct. Connector. How much you got right so far? 2 out of 4? Alright. This one, okay, so you only got 2 wrong. Not bad. Not bad, not bad. Not bad. So now I want you to draw a simple flow chart for me. I want to draw a flow chart. Think of a problem, something simple. How do you want to draw a flow chart of? I leave it up to you.
Can I draw it based off the video?
Oh yeah, sure. Sure.
With the T button and
Sure. Let's see if you go. Let's see you can draw making tea. You have many solutions to a simple problem. When you're finished, we'll see. Okay, let's look at what you have so far, right? So here you have start the program, okay, and then what you have here. Let's bring up back the photograph. So you start the program here, right? This is the start. So what is it that you want to happen here? Oh, so you want to, no, but you already have the kettle. So what you want to put here? Probably what you could have here is input, right? Add water, right? Add water to kettle. Yes. And what else after you add water?
After get the cup and tea bag.
Well, you could do that. You could do that. Or light the stove. So you could have yes. Actually, alright. You can let here be a decision whether or not you want to light the stove yet or not. If yes, light stove. If yes, you move on to the other step. If no, you'll add more water. Because suppose the kettle don't feel like it having enough water. So you add, if no, add more water until you're ready for lighting. So when you feel like it's heavy enough, you move on to the next stage. Which is, well, it can't work right here, so kettle is boiling. Add the tea bag, you get your cup. What's going on here? Okay, but what's supposed to be here?
Like if the water is into 2 minutes of boiling,
Yeah.
till it's ready,
Yeah.
for you to boil the tea, you would
Oh, so you have a decision here. So if it's not boiling yet, it goes no and it comes back around until it's boiling. So when it's boiling, it comes here. So then what else should be here after it's boiling?
milk.
Oh, if you
Decision making. If you want to add milk to it.
okay, so you say if you want to add milk. Add milk. Yeah, that's a very funny shape, that one. Add milk. If it's yes,
You can remove the tea bag.
remove tea bag. No, but okay, remove tea bag. Yes.
And
Well, you can end it after you remove the tea bag. You end it. You don't have to go any further. Then you end it. So basically, you got the gist of how it works. And the flowchart is you can have some very long flowchart for some very long programs, and you'll understand it as long as you're following the arrows. That's the beauty about flowcharts.
so the input.
Yes.
By the input, like if you want to add like sugar or those things in it, that would be your input.
Yeah, that would be your input.
Also, the input could have go after the milk or before the milk.
Yes, it could. Yes, it could. So as you see there, you can have one problem, and you can design several solutions for the one problem. So you can have, I could come up with a different flow chart as opposed to you, and it would still work. It would still work. So from your understanding of flowchart, tell me what you get from it.
From the flowchart, I get to know you can the shapes you should start with.
Yes.
How you should end it.
Yes.
You got like based on the example of the board. Like for the input that I just asked.
Yeah.
Like for the sugar or the milk, that would be your input, and add water. That would be a part of the process going down to like the stove. If you are not comfortable.
Yeah.
If you're not comfortable with the amount of water in the kettle,
Just go back around.
But if you're comfortable, you want to continue to go down, which would be the cup and the tea bag. So if the tea bag is enough, you would continue the step to 2 minutes, which would be 2 minutes of boiling. So if you feel the water is hot enough, you would continue go around to add milk. But if you are not comfortable with the water, you would go back up and add some more water to the kettle.
Okay, so you receive a 90% passing grade. 90%. I'm very pleased that you understand, and that brings it to the end of your class. Good morning. This is my reflection on the micro teaching exercise that I did. I did 2 exercises, one on pseudocode and the other on flowchart. Those are the 2 classes that I decided, the 2 topics that I decided to teach in IT computer science. First off, let me start off with the pseudocode aspect of the micro teaching that I did. In that first thing that went wrong is, well, in watching the video of me teaching, I realized that I was stuttering a lot. I don't think the material flowed as well as how I wanted it to, because in the back of my mind I was still thinking of the 15 minutes, and in trying to teach the class and thinking about the time constraint. I think that caused me to not flow as how I wanted to flow, or how I intended the material to come across. I did miss some things. So for the pseudocode, it was supposed to be 15 minutes. I think it rounded off to almost 13 minutes. Probably 3 minutes out of it was a recording from YouTube, where I shared with the class an interesting video on pseudocode. I think I had a good engagement with the student, because he seemed to be interested in what was being taught. I think I had a good control somewhat of the material and charisma in getting the energy up in the class. For the flowchart, on that one I went over the 15 minutes, because I think that's a topic I felt even more comfortable about, and in knowing that I did only 12 minutes in the previous class, I went over the 15 minutes. So I think the time constraint was a factor for me, because when I'm not thinking, before when I was thinking about the time, I'm cutting before the 15 minutes. Now when I try not to think about the time, I'm going over the 15 minutes. I had to even use a timer. But in teaching the flowchart, I implemented, or I used a whiteboard to assist in helping the student, because to help the student get a better understanding of the symbols in flowchart. So what I did, I used the matching pair, where you have the symbols on one side and the words on the next, and the student would actually match it. I think that this was a very good technique to use in the class, because it's a fun game while you learn, and everybody, well, most persons like matching from primary school. So I thought it was a good way to go about it. And I realized in the flowchart I was getting a lot of feedback from the student, which was good. I didn't expect that, and he said he understood, and I could see where he was learning. I could see that learning was taking place. He gave me his feedback, so that the class was also good. I think I could have controlled the material better in watching the video. I see where I could have done a lot better in delivering the material. So that is basically my reflection. So a lot of it was me how the order in how the material flowed. The order was a bit mixed up for some of them. Okay, thank you.